Have you ever stopped to think about what your home's most critical systems are really up against? It's not just basic wear and tear. No, it's a daily, knockdown, drag-out battle with your local environment. We're going to take a look at one town where this fight is absolutely brutal and what it can teach every single one of us about our own homes.
So, what is it? What makes one specific place a perfect storm of challenges for something we all count on, like our air conditioner? To figure that out, we're zoning in on a town called Conroe, Texas.
To really get what's going on, you have to understand the place. See, Conroe isn't just hot. It's a uniquely hostile environment for pretty much any kind of heating and cooling technology.
Let's just boil this down to one number, 110 degrees. That's the feels-like temperature in a Conroe summer. For an AC unit, that's not just a hot day. It's a relentless, non-stop siege, forcing it to run at full blast for months on end.
But it is so much more than just the heat. There are basically 4 local bad guys waging a constant war on these AC units. You've got that thick, soupy Gulf Coast humidity. You've got shifting clay soil that literally moves the ground under your house. Add in weird microclimates from the nearby lake that trap moisture, and top it all off with a thick blanket of pine pollen that can literally choke the outdoor unit. I mean, it is a full-on, multi-front attack.
And here's the real kicker. An air conditioner here is like a marathon runner that never, ever gets a break. It's running for 8, 9, even 10 months out of the year. That kind of relentless grind just isn't what these systems were designed for. And all that constant stress leads to one inevitable outcome: failure.
And when these systems finally do give up, the failures aren't random. Nope, they are super predictable, always frustrating, and they always seem to happen on the absolute hottest day of the year, right? Let's walk through the classic symptoms.
First up, the ultimate insult on a blistering day. You feel the fan kick on, but the air coming out of the vents is warm, maybe even hot. That's the #1 sign that your system is officially losing the battle against the heat.
And then you start to hear the noises, that awful grinding, that high-pitched squealing, or that banging and clanking. You know, that's not just an annoying sound. That's the sound of mechanical parts literally working themselves to death under the strain. You might also start to notice a weird, musty, kind of moldy smell. Yeah, that's often a direct result of all that humidity we talked about. It's creating the perfect breeding ground for microbial growth right inside your ductwork. And maybe the most obvious sign of trouble, a puddle of water forming around your unit. That is a huge flashing red light that your system just cannot handle the insane amount of condensation it's pulling from the humid air anymore. Now, this all leads to a really common problem that has a technical name: short cycling. This is when your system constantly kicks on, runs for just a few minutes, and then shuts right back off, over and over again. Not only is it incredibly inefficient and wastes a ton of energy, it also causes major premature wear on your system.
And you can draw a straight line from each environmental threat to a specific system failure. That crazy high humidity? It leads to clogged drains. The extreme heat? It absolutely cooks the capacitors that are needed to start the motors. The shifting clay soil can literally crack open refrigerant lines, and that thick pine pollen clogs up the coils, basically suffocating the system. See? Each thread has a direct mechanical victim.
Okay, so you're facing this total onslaught. How in the world do you fight back effectively? Well, it's not just about having the right tools. It's about having the right philosophy and a really clear, methodical process.
And this quote really gets to the heart of it. In an environment where systems are constantly breaking down, trust is the most valuable currency. A good technician's goal isn't just to make the most expensive sale. It's to provide an honest diagnosis, even if that means a simple repair instead of a costly replacement. That whole philosophy translates into a clear 3-step process. First, a thorough diagnosis with a transparent written quote: "No work starts until you give the okay." Second, the repair or installation gets done correctly, to code. And third, and this part is crucial, the system is tested under a full load, and then they follow up a few days later just to make sure the fix actually holds up. So how does all of this translate into an actual strategy for a homeowner? Because in a climate like this, every single resident eventually faces one big, expensive decision.
And here it is, the core dilemma: repair versus replace. Do you just repair the immediate problem, which costs less right now, or do you replace the whole system to solve those underlying issues of age and inefficiency? That costs more upfront, but it could save you a ton of money down the line.
So how do you decide? Well, the source material gives us this fascinatingly simple rule of thumb called the $5,000 rule. You take the estimated cost of the repair and you multiply by the age of your unit in years.
If that number is over $5,000, then replacement is probably the smarter financial move. And if you do decide to replace it, this quality checklist is absolutely non-negotiable. It's not about brand names, it's about technical standards. For instance, manual J and D calculations are industry standards to make sure the new unit and ductwork are perfectly sized for your house, not too big, not too small. Proper refrigerant charging ensures efficiency, and pulling permits means the work is inspected and up to code. These are the details that separate a system that lasts from one that fails prematurely.
Okay, so what's the big picture here? What can we all learn from the battles being fought on the HVAC front lines down in Conroe, Texas?
First, let's manage our expectations. In a really demanding climate like Conroe's, an HVAC system's average lifespan is only about 12 to 15 years. The environment is the single biggest factor that dictates how long your equipment is going to survive.
And this is the most important lesson of all. It's not just about the heat. It's about that unique combination of humidity, soil, pollen, and those local microclimates. Your specific neighborhood is the ultimate boss. It dictates your system's needs, its performance, and ultimately its lifespan. You have to be prepared for your specific battleground.
So we'll end by turning the question back to you. It doesn't matter if you live in the humidity of Texas, the dry heat of Arizona, or the freezing winters of Minnesota, your climate has its own unique set of antagonists. Knowing what they are is the first step. The real question is your home's most critical system truly prepared for its fight?